Okay, so the last thing we're going to be talking about in terms of probability is counting principles and factorials. So the first thing we're going to talk about is called the fundamental counting rule. So it says, given two trials, the first trial has m different outcomes, and the second trial has n outcomes. The number of different outcomes, then together the two trials can have, what we're going to do is, this is probably makes a lot of sense, but it's going to be m times n outcomes. This is very helpful for finding the number of items in your sample space. So again, this is going to be pretty intuitive for some of you, especially this first one, because you think about it, we're going to flip a coin twice. So on the first flip, I could get a heads or a tails. So that's two outcomes. Then we're going to flip a coin again, and there are two outcomes for the second flip. So the total number of outcomes are 4, and we could figure out, I could name those heads, 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 tails, tails, heads, tails, tails. So those are the 4 outcomes. Now there are a few more if we roll 2 dice, because when I roll a die, we're assuming this is a 6-sided die, there are 6 outcomes for the first roll, and then there are 6 outcomes for the second roll, so that's a total of 36 outcomes. Finally, flipping a coin and rolling a die. If we flip a coin, there are 2 outcomes. When we roll that die, there are 6 outcomes. That gives us a total of 12 possible outcomes. Now, it doesn't just have to be 2 trials. So we could extend this to more trials. So let's say, find the total number of outcomes for randomly guessing the digit PIN number for a friend. So let's say you have a friend's ATM card and you plug it in and you just want to take a guess. Well, when you take a look, what are the possible outcomes on one of those in terms of the digits we can choose? We can choose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 different outcomes for the first number. Times, same thing for the second, right? Times how many for the third number? There are 10 different ways. And then finally for the fourth, this is 10. 10 times 10 times 10 times 10 is 10,000, right? Yep, so there are 10,000 different outcomes for your friend's PIN number. What is the probability of randomly guessing your friend's 4-digit PIN number? Well, they only have one combination that they've chosen out of there are 10,000 to choose from. So the probability that you guess your friend's PIN number is 1 out of 10,000. That would be pretty unlikely, correct? So given a newer car Ohio license plates have 26 letters, followed by 3 digits, followed by 2 letters, what is the probability that a random Ohio car has the license plate HC290LB? So random procedure, we're going to choose a car from the parking lot, choose an Ohio license plate from the parking lot, find the probability that it has that license plate. We need to figure out how many different possible license plates there are. So when I think about it, how many letters do I have to choose from? Well, there are 26 letters in the alphabet. So I have 26 for the first choice and 26 for the second choice. Now the next 3 are going to be digits. So it's 10 times 10 times 10. And then finally, we have 26 and 26 for the last 2. So if we look at this in terms of exponents, how many 26s are there? This should be 26 to the 4th power times 10 to the 3rd power. So let's do that. It's going to be 26 raised to the 4th power times, I'll use parentheses, it's not necessary, but 10 raised to the 3rd power. A lot. So it says, I think this is 456,976,000. 456,976. So 456,976,000. So that is a lot of combinations. I think that's more than there are cars in Ohio. So now what's the probability that a randomly chosen car has this specific license plate? Well, there's only one of those out of the total number of possible combinations. So 456,976,000. And this would be the probability of guessing that specific license plate.